Okay, welcome to Algebra 2, Semester 1, Unit 6, Section 5.6. In this unit, we're going to look at finding the rational zeros. Now remember the last unit we discussed when you come out with factors that are, say, like x minus 2, x plus 3. You set each of those factors equal to 0 and solve. This one would be equal to 0 when x equals positive 2. This one equal to 0 when x equals negative 3. These are the solutions of the points on the graph where this particular polynomial would cross the x-axis. X at negative 3 and x at positive 2. Okay? And that's really what that means. Those are the zeros. Now, rational zeros simply means that we can actually find them on this number line as rational numbers. And there's still points where it crosses the graph, and there's still going to be factors of that. So, to find all the possible rational zeros, all we do is we use this formula. We take the factor of the constant term and divide it by the factor of the leading coefficient. Okay, so if we come down to our samples here, I just put 2 so that we could work them at the same time, but I want to actually mark this one out and give you a simpler one so that you can just picture it in your mind's eye of what's happening. So if I give you, let's write in there, instead of that one, let's write in 2x squared plus 5x minus 3. Now, if we were to work this out into factors, the factors for that would actually be, and I'm not going to work them out, you're just going to have to trust me here for a minute. The factors would actually be 2x minus 1 times x plus 3. So if we solve that, we would have x equals negative 3 for 1, 0. And x equals, bring the 1 across, that would make a positive 1, divided by 2 would be a positive 1/2. So, those are our actual zeros. And so we're saying on a graph that it's crossing at negative 3 and up here at 1/2. Okay? Now, let's look at how this theorem works and how we can use it to kind of shortcut things and, well, not really shortcut, but it would allow us to see all the possible zeros. So we take the factors of the constant term. Well, the constant term here is 12. Here is negative 3. So for 12, we have 1 and 12. It could be negative 1 and negative 12. So we make sure and we show it as the possible positive and negative. In addition, we would have 2 positive negative and 6 positive negative. Next we would have positive negative 3 with positive negative 4. So we have all those factors. On the one that I gave you, we would have positive negative 1 and positive negative 3. Okay? Next, the factors of the leading coefficient. Well, leading coefficient here is 1. Leading coefficient here is 2. So over on this side, the factors for this one would just be plus or minus 1. For this one, it would be plus or minus 1 and plus or minus 2. Now we have to look at the possible rational zeros. So we just take this and put it over top of this one. So we have plus or minus 1 over 1. plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12 over 1. And here we would match each of these with that 1, so it's plus or minus 1 over 1, plus or minus 3 over 1. And now we go to this one, plus or minus 1/2, and plus or minus 3/2. Now we go ahead and we simplify further. We get rid of the fractions where we can and just write the whole number. So 1 over 1 is equal to 1. 2 over 1 is 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is 6. And 12 over 1 is 12. Those are our simplified list of possible zeros. On this one, plus or minus 1, plus or minus 3. Now the last two really are fractions. You could put them into mixed numbers. I never do because sometimes you have to plug them into things. So plus or minus 1/2, plus or minus 3/2. As long as they're in those terms, they're fine. Okay, so next page. We list the factors of the constant term. 15 and -6. Factors of 15, plus or minus 1, plus or minus 15. Plus or minus 3, plus or minus 5. Last one, -6, be a plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay. Factors of the leading coefficient. Here it's 1, and here it's 2. So, for this one we would have plus or minus 1, plus or minus 2. Here we would just have plus or minus 1. Possible rational zeros. This is when we get into the fraction. And I've placed it with the constant above the coefficient for a reason here so that you can just match them up. So we have 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, plus or minus 15 over 1. The next one, we have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1. Next we would have plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. Okay. Very last thing that we're asked to do is simplify our list. This list, they're all whole numbers. They all have a 1 on the bottom, so I can just simply write those whole numbers. Or integers, I should say. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Over here, I have 1, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and then notice how the 2 over 2 is equal to 1. We don't need to list it again. That's how come we call it a simplified list. 3 over 2 we don't have, so plus or minus 3 over 2. And 6 over 2 is equal to plus or minus 3. So we finished that. Now, in the book, you won't need to do them side by side. I simply did that so that you could be practicing the same skill over and over. Okay. In the previous lesson, we found zeros when given 1 0. Now we can find all the possible zeros when not given a 0. Now we must learn how to determine from the list of possible zeros what the true zero values are. In other words, I'm going to give you a factor and ask you to find the zeros. And you can do this now because you know how to determine what the possible zeros are, and then you'll just plug those in. So here we go. This is how it's going to look. Given a polynomial, factors of the constant term, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Okay, leading coefficient factors. Leading coefficient up here is 1, so it's just plus or minus 1. Possible rational zeros and the simplified list we can put together simply because we know that they're all over 1, so they'll be whole numbers. So we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Okay. Now we have to just test those using synthetic division and see which ones work. So if I start at the beginning of the list here, and I say, okay, I'm going to try 1. So I take 1, and I plug it in. Now my coefficients are 1, negative 8, 11, and 20. Make sure they're in descending order. X cubed, x squared, x, and x to the 0th. Okay, we bring the first one down. 1 times 1 is 1. Bring the second one down. 1 times negative 7, negative 7. 11 plus negative 7 is 4. 4 times 1 is 4, and that makes a remainder 24. So we know that negative 1 is out. Now we'll try another one. Let's just try positive 1. Sometimes these take a while to get them. 1 drops down. 1 times 1 is 1. Negative 7. Negative 7 from 11 would be just trying to find where I'm at. Well, I'm sorry, I did 1 twice. I meant to do one of these as a negative 1. That's why I was looking too familiar. Let's make that a negative 1. Now we drop down 1. 1 times negative 1 is negative 1. 8 and 1 is negative 9. Negative 9, negative times a negative is a positive. So 11 plus 9 be 20. 20 times negative 1 is negative 20. And that makes a factor because it's got a remainder of 0. So when x equals negative 1, it's a 0. But when x plus 1 is a factor, then it's a 0 because it has caused this answer here. So that's a factor. Now we need to break this down and see what other factors we have. That's x squared, x to the first, and that's it. Okay? So let's see, what else could we have? X squared minus 9x plus 20. I can shortcut this. 20 is positive, but the middle number is negative, so I make it all negative. That would be 4 and 5. So my three factors are x plus 1, from the work in here, then x minus 4 and x minus 5. Those are my factors. So in order to make those zeros, I have to set each one equal to 0. So it would be x equals negative 1, x equals 4, and last one is x equals 5. Okay, I think that's the end. Nope, it's not the end of that video. Okay, we have another rational zero theorem, and I want you to work through this one on your own. Follow all of the steps. When you come into class, we'll check it. Down to the bottom of this page, it says, note our samples have all leading coefficients of 1. What do you think will happen to the list of possible zeros when the leading coefficient is increased? Well, all of ours did not have 1. We actually had, I'm trying to look back in my other set of notes here, we actually had the very first one that I gave you that we marked out and put the other one. It has a 2 in it, so its leading coefficient is not 1. And then on the last page we had one that was not 1. So let's look at what happens to their number of possible zeros. Here we go. Because it's not 1 here in the front, that means that your factors of leading coefficient becomes more than just 1. See, when this one has just a 1 up here, it's just 1, plus or minus. So that reduces it significantly. And that's what it's asking is, how do you know? Okay. What do you think happens to the list of possible zeros when the leading coefficient is increased? Well, as the leading coefficient is, this leading coefficient becomes, becomes bigger, this leading coefficient becomes bigger, the possible zeros okay, so you can see them right here on the graph. There's one there, another there, another there, and another there. So that quadratic has 4 zeros, 4 rational zeros. We're not going to work them all out. I'm going to let you come to class and do this assignment. And then I need to have you show me these problems from the notes that they're done. You can even finish them in class. So thank you very much.